This video will focus on 10.4, and we're going to kind of review what we did in the last session where we had like 5 to the fourth and 5 to the second is 5 to the sixth divided by 3, or divided by 5 to the third. And in this case, it would be 5 to the third altogether. But take a moment, pause the video, make sure you get these right. You should get 5 to the third, 2 to the third, 4 to the sixth, 8 to the 12th, c to the fourth, and n to the 10th. And we want to really look at how you evaluate non-zero numbers with an exponent of 0. And then how can you evaluate a non-zero number with a negative integer exponent? So if I look at all these different values here, notice how they're all like 5 to the third over 5 to the third. Well, in this case, if we think about what we learned yesterday or in the last session, it would be 5 to the third over 5 to the third. And that really means 5 to the third minus 3. And that can be rewritten as 5 to the 0 power. Now, a lot of people have the misconception, they think that this is equal to 0, but it's really not. Remember, if I take 5 to the first, I get 5. 5 to the second equals 25. 5 to the third equals 125. And if I want to go backwards, I'd have to divide by 5, right? Like 125 divided by 5 is 25. 25 divided by 5 is 5. 5 divided by 5 is 1. And then if I do 1 divided by 5 here, I get 1/5. And that's why negative exponents are just the reciprocal of these right here. So if you have 0, remember that it always equals 1, regardless of the base. Unless it's 0, I guess. So all of these answers here will be equal to 0. Like negative 3 in parentheses to the 0 power. And that will equal 1. Every one of these. And that's basically what we're doing for these right here. Same kind of thing where you look at it and I have negative 3 and 3. If I add these together, I get 5 to the 0, which equals 1. These will equal 1. This will equal 1, and so on. So the key idea here is that if I have numbers like 4 to the 0, that will equal 1. And if I take 4 to the negative second, I can rewrite that as 1 over 4 to the second. It's just the reciprocal. It's 1 over it. So that's what this shows us right here. So for a couple examples here, if I look here, if I have 3 to the negative fourth, well, what we want to think about is if I have 3 to the negative fourth and I want to keep this positive, I would really do 1 over 3 to the fourth. It means the same thing as 1 over, or 3 to the negative fourth. This one here, if I have negative 8.5 to the fourth times negative 8.5 to the positive fourth, this will equal 0. So this would be equal to 1. And then this one here, if I look at it, and if I think about this for a second, I really have like 6 of these 2's. So 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5, 6. Over 8 of them, right? 1, 2, 3, 4, 5, 6, 7, 8. When I divide these off, that equals 1, 1, 1, 1, 1, 1. And now I'm left with, like, on the bottom, 2 times 2, which is 2 to the second. And then on top would be a 1. Or I could rewrite this as 1 over 4. Just so you know what this means here. So when I look at this, I could rewrite this as a couple of things again. I could write it as 1 over 2 to the second, because that's what I have left on the bottom. There's 2 more than the top, right? And if I want to rewrite that, I could rewrite it as 2 to the negative second, or 1/4. They mean all the same thing. So now we're going to look at this here, and I have 4 to the negative second, and I can write this a few ways. I could write it as 1 over 4 to the second, or I could say 1 over 16. But that's what this means here. This would be negative 2 to the negative 5th power. And I can rewrite this as 1 over negative 2 to the 5th power. They mean exactly the same thing. This one here would be 6 to the negative 2nd power. So 1 over 6 to the 2nd power. This would be 1 over negative 3 to the 1st power. And I'm doing that because the bottom number is larger than the top, right? So it's got to be the negative 3, there's got to be 1 more on the bottom. Otherwise, when you cancel out, make 1s. That's what I'm doing. For this one here, I have 5 to the 7th, and I have 5 minus 4. Well, in this case, I just take 5 to the 7th minus 4, and I get 1 over 5 to the 3rd. This one here, I'm going to get rid of this up top, so I'll have 4 times 5, or to the 5th power, so 5 minus 3 is 2. And then this would just kind of become 4 to the 1st power, so this will be a 1. This here will be equal to, this is interesting because it's not in parentheses, so it's really important to pay attention to this. That if I have negative 5x to the 0, that is not the same as negative 5x to the 0. Let me show the difference. This one here would just be equal to 1, right? This one, the way that it's written, would actually be just touching the x. So it'll be negative 5. And then it's this right here would be times 1. So it goes away. This one here is 9. So my 9y stays the same. Oh my goodness. Y to the 8th. Because this would come on down here. And that would be like 5 plus 3 is 8. So that's how I have that. So pause the video, try to solve these. Here are your various answers. Make sure you pay attention to this, how they're not in parentheses, and that's why this 8 will stay on top. That's why, well, I guess that's really the big one. Here's another one. This is a trickier one. It says how many water or drop of water leaks from the faucet every second. So I have to figure out for an hour. So I have to first of all figure out how many seconds are in an hour. And if I do 60 times 60, I get 3,600. So it's 3,600 times 50 to the negative second, which is really 1 over 50 to the second. So it'll look kind of like this. So I have this 3,600 times 1 over 50th to the second. That will become 2,500. And that is going to be 3,600 over 2,500, which will equal approximately 1.44 liters per hour. If we change it, so instead of being leaking at the rate of 5 to the second or 50 to the second, it's now going 5 to the negative 5th. Oh, I'm sorry. This will be what it leaks at, 5 to the negative 5th per second. So now I'll do the same things I did before, but now I'm going to have divided by 5 to the negative 5th instead of 50. So for this one, I'm going to do by 3,600 times 5 to the negative 5th. When I rewrite that, I'm going to have 3,600 times 1 over 3,125. So then 3,600 divided by 3,125 equals 1.152 liters per hour. So that's pretty much the lesson.